Okay, so inside of the setup structure, we're going to say void setup, open parentheses, close parentheses, open curly brackets, and then down here, close curly brackets. Okay, so what does this mean? So we said setup is actually a method or a function, and so it follows the format of any other function, which we'll be getting to talking a little bit more about in a little bit. But for now, what we can note here is that setup is the method. The parentheses mean that it doesn't require, it's empty in between, so it doesn't require anything to run to use this. And void is a keyword that means that it's not going to return anything as a result. So void setup is going to be one of your standard building blocks that you type out very frequently. All right, and then we have to internalize these actions inside of the setup method. We need to use our curly brackets to open and close, and this will define everything that happens inside of void setup. All right. So let's go ahead and execute these two lines, and this should be familiar. It's the same thing that we did in the last exercise. So we'll define a size. I'll just use the same one that I did before. And background. And here I want to start to use a white background. So I'll say 255 and semicolon. All right, and if we were to hit run, all right, we'll get a display window that is 400 by 400, and nothing's happening yet, right? Because our setup structure is successfully defined with these two lines of code, and so everything's working relative to setting up the display window. All right, so if we've typed that out and we don't have any errors, let's go ahead and look at one additional thing that's pretty helpful. If we were to go to Edit, Auto Format, that's also Control-T, we'll see that whenever we open a curly bracket versus whenever we open and close a curly bracket, that's defining a block of code. And if we do the auto formatting, everything that's inside that block of code will be indented 2 spaces over, right? And this is a way to have your program stay nice and tidy, as well as if we don't have all the key elements required from the processing syntax, it will not indent all the way. So if I hit Control-T, or you'll see as an alternative down below, excuse me, we'll see that this part was also indented. So that's an indication that our structure hasn't been completed in terms of the setup. So if I hit Control-T again, you'll see that this bounces back over and everything's happy. All right, so let's carry forward and do the same thing for the draw portion of our file. So we'll say void draw, again, open parentheses, open curly brackets, and then down here at the bottom, I'm going to close my curly brackets. And as a general best practice, a tip, whenever I open a curly bracket, I always close it immediately so I don't forget to do that and accidentally leave that open. So again, if I hit Control-T, this should indent this part of my pseudocode successfully. And then we can go ahead and just type in the last 2 lines of our program. Okay, so the stroke color, this should be familiar. I'll do the same color that I used a second ago, which was, I think, kind of cyan, 0 to 150, 255. close my parentheses, make sure that I have a semicolon. And now the last step here is that we want to draw a line. And this is going to be just like we did before. And remember that the inputs, this is just a note. This isn't going to work if I use this format. But it's from x1, y1 to x2, y2. So those are the inputs that are required. Well, since we've got a display window that we've defined as having a width and a height of 400, x1 and y1, we can actually use the properties of the display window to define the center. So if we were to then go back and change the size, it would still maintain its starting point at the center of the window. And the way to do that is we can use the keyword width. You'll see it's now highlighted in pink. And if we divide it by 2, right, that's half of the width. So that will give us the x position at 200. In the same way, we can use height over 2. And then we just need to specify how we're going to get the mouse's position, right? So we could type in a coordinate like, let's say, 50, 50, right? And this is going to run, and even though this looks static, it's actually refreshing at 30 frames a second and drawing a line, right? To that, from the center to that position. So this may look static, but it's actually running continuously. So in order to see difference, this coordinate here and here need to change each frame, or we need to have some way of changing them each frame. So let's use the mouse as a way to test that, and we're going to type in mouse X with a capital X, and the same mouse Y. Again, these special keywords are highlighted in pink in this version of processing and are a way for us to visually recognize that we have some special terms that we're using here. These are just the properties of the mouse, where it is relative to the display window, in the same way that width and height are properties of the display window that we can access. So if we hit play, right, as I'm moving my mouse around, it's continuously drawing lines, right? So I can start to use this as a kind of etch-a-sketch or spirograph and draw lines of varying length based on where my mouse is. So now we have a very simple interaction by grabbing the mouse's position from the user. After a while, because this is running continuously, it's going to get really muddy. So if we want to run it again, just hit run, and we've got a new sketch pad. And now we can draw a shape. If I move my mouse off the display window, then I won't have, it won't keep drawing new lines. It's drawing over the last line over and over again because that's the last mouse position it captured. But it doesn't look like it's really doing anything to us until we move our mouse back over the display window. Okay, so there were a couple of questions that came up during this exercise that we'll address now. If you have any others, feel free to drop them into the questions window. The first of which was, why do my shapes look choppy if I'm using an ellipse, or if I look at the diagonal line that's kind of terminating up here, how it looks choppy? So remember, the coordinate system for processing is based on pixels, right? So any line that's going diagonally is actually going over, down, over, down, over, down, over, down at the level of the pixels. So just like any other computer graphics application that you're developing, or if you're working in Photoshop, when we're working with pixels, they're squares, and it's more difficult to display a rounded or diagonal shape with those squares unless we use a property called anti-aliasing. So we can, and of course, processing is using a library to access the computer graphics properties to draw these pixels, and it's either using in version 2, it's a special OpenGL library that's been developed for processing, But if you wanted to have less choppiness in your shapes, inside of the setup window, we could type in smooth, which is a method that will smooth out the shapes relative to their anti-aliasing. So if I draw a diagonal line here, you see it should try to do a better job of smoothing out those shapes, which besides that one, because I think this actually overlaps right here, it looks still choppy. If you look at the single lines, they should look more smooth. Okay, and another question that came up was void. All right, so whenever we're using a function, so that might be a way to see that a function is being used is to see the curly brackets. Whenever we're using a function, void means nothing, right? So in this case, this function is not meant to return anything, right? In contrast, we'll be looking at this in a second, but if we wanted our function to return an integer, it might look something like int return an integer. This is my function that I'm just about to create. So I'll set it up in the same way. Right, so some action is going to happen in here, right? And I would return an integer. And again, we haven't talked about integers or functions yet, but as a reference, this might be a sample function. And if I were to use the return integer function somewhere, I would have to say int my variable equals return an integer. Right? So running this function stores the result, which is an integer. Right? So we don't want anything to be returned from this function, and these functions, these two here, setup and draw, aren't actually set up to do so. So we have to say void, or in other words, we're telling the computer, don't worry about returning anything to me whenever you run this. Just run the function and whatever is inside. Okay, really great questions. So let's go ahead and carry on then. This file was my user input file. So I'll save that. All right, and let's bounce back to the presentation.